Okay, welcome to our post-fall break CS40 class. Apologize for the slightly late start of class today. It took me a few extra minutes to get Zoom and stuff all set up. But I hope you all had a good, restful fall break. Today, we're going to talk, just real quick review grades about, there's a lot of stuff that's been submitted recently, so we'll talk about that. And then we'll talk about your next homework assignment and a quiz for next week. There's two handouts up here up front. So if you haven't gotten both of those, then make sure to get those. So yeah, so grades real quick. So with the last quiz, everybody, there are lots of really good scores. Highest average that we've had so far. I was very happy with that. A total of 35 students, so about 2/3 improved the grade on one of your previous quizzes. I've already entered that in and already updated your previous quiz. So you can go in and check what that is like, and yeah. And the average grade boost was almost 2 points for students, so that was great. And then there were 3 students which got either a +10 or a +8 on your quiz, so that was also a big grade improvement. So I hope everybody's pleased with how the quiz turned out, because I'm pleased with it. The lab from last week. Again, the lab had some extra credit, so the average was above a 5, 5.1, and 19 students chose to complete the extra credits. The homework that was due last week, homework 1. Again, I think many of you found the homework to be rather long and difficult, and that was intentional. It was supposed to be a longer and more difficult homework. But still, everybody did very well on the homework. The average was so 17.4, so pretty high. The highest score was a 22.5, which is not only doing the extra credit that I offered, but suggesting some additional extra credit as well. And there were 3 students who invented their own extra credit, and I gave you all extra credit for doing that. Any questions about any of the quiz lab homework grades? Anything admin related to that? No? Okay. So grades overall, average rose about 3% over the past week, so that was nice. And everyone in this class is can still get an A if you'd like to. And again, we talked last week about this being a hard class, and the general consensus of everybody in the class is that this is a hard class. But I also want to emphasize still that it is a doable class if you put in the work, and it's a lot of work, but if you do it, you can get a good grade. And another just quick reminder of sort of the philosophy of the assignments and the grades in this class. So according to Google's vice president in charge of hiring, this is a direct quote: GPAs are worthless as a criteria for hiring, and test scores are worthless because they don't predict how productive an employee will be. And so if you want to read more about that, this New York Times article interviewing with Google's VP in charge of hiring. And so this is only Google's opinion, but basically everybody else in the industry follows what Google does. And yeah, so whether Google or any other company, this is more or less their philosophy. And so these grades, a lot of students think about grades as like it's something that you show your future employer, and they're going to use that to determine whether to hire you or not. And if you are a data science major, that is not really going to be applicable to you. Instead, what the people who are hiring you are going to care about is they're going to want to know what projects have you worked on in the past, and they'll want to see those projects. And based on those projects, they'll see like, okay, your skill set fits or does not fit what we need for our company, and make the hiring decision that way. So when we talk about this next assignment here in a little bit, we'll talk a little bit more about how all the assignments in this class are really directed to help you get jobs. And one last, so we're going to talk about the next assignment here in a second. But before we do that, just a quick warning. And I don't have any particular reason to give this warning. I'm not thinking of anything in particular. I just want to remind you all of this about the collaboration policy in the class. We mentioned this on the syllabus day, but I'd like to just remind you again, and that's that if you're working too closely with other students, probably I'm not going to catch you and turn you in for plagiarism, but the real problem is that you won't learn the material and you won't get a job. And so again, as we'll see, as you can see for yourself if you follow the links here and on the syllabus, that grades are not the thing that people care about when they're hiring new employees, even straight out of college. Instead of looking at your transcript, employers will look at your portfolio of projects that you've completed. And so the assignments in this class are designed to help you build that portfolio, and we'll talk about that here in a second with our next assignment. But before doing that, any questions about anything admin-wise? Okay, so let's come over here and accidentally closed our assignment tab. So the week 2 homework, we've talked about everything that you need for the homework at this point. We just actually haven't talked about the homework itself. And so the idea of this homework is it's going to be a little bit more free form than the previous homework. The previous homework, you had a bunch of very concrete doc tests that you had to pass. This one is going to be, you're starting everything from scratch. There's no like pre-given code or anything. And so you have to do it all, put all the pieces together. And the basic idea is that you'll perform a simple data visualization on a data set. You get to choose the data set, and then you'll create a web page explaining why your visualization is cool. And so the due date for this, it's pretty soon. It's this coming weekend. My hope is that you will find this assignment easier than the last one. And since you get to choose the data sets, you can visualize something that's maybe interesting to you, and so it'll hopefully be a little bit more fun too. Because this assignment is due on this weekend, there's not going to be a specific lab for this week. We'll still have lab class on Friday where you can work on this assignment and ask questions. And there'll also be an extra credit lab assignment, but there's not going to be like the normal 5-point required lab assignment due on Sunday. And again, you have the 48-hour extension if you work with anybody. So Tuesday would be the deadline that way. So instructions, you have to find 2 data sets that are interesting to you and download them. There's 3 suggestions here of places to look for data sets, but you're welcome to use whatever you want. If there's something, you're taking an econ class or something and there's data sets in that, feel free to use one of those. Anything that you want, doesn't matter. Let's see, the links up here, most of these will be in the JSON format, which we've discussed in class. Some data sets will be in the CSV format. It's another common format for data sets. The book has a chapter on that. We're not going to explicitly cover it, but it's fairly easy, like working with JSON. So if you do find something in CSV format, don't be afraid of that. It's just as easy to use as JSON. And then with those 2 data sets, you'll generate 2 plots, one from each of your data sets. And there's a handful of requirements here that the plots must satisfy, but let's just come down here and look at some examples. So here is one example of a plot, so a bar plot of the data that you collected in the last lab of analyzing President Trump's tweets. And here's some of the words that I searched for and the number of times they occurred. So that'd be one plot. And then down here is a line plot. And this is the number of times that Trump mentions Obama or the word Russia, now spread over time instead of comparing different words directly to each other. And so just two simple plots like this is all you're required to do. They must be two different types of plots. So in class, we covered how to do bar plots. Today in class, we'll see an example using line plots probably. But any other type of plot is fine. And again, we're not going to cover all the details of everything that you need for doing this assignment. So you'll have to specifically reference the documentation of the library and the tutorial that's referenced in the class notes in order to be able to do this. So some examples of things that you're required to do that we're not going to explicitly talk about is providing a y-axis label like this and making the x values here a little bit sort of nicer. This isn't a particularly nice one, but this is an acceptable example of x labels because the labels don't overlap. You can actually read them. Something that's an example of something that's not acceptable would be something like this down at the bottom where the things overlap and are ugly. And so yeah, example of something that's not acceptable. Because there's no like specific doc tests for this assignment, the grading will be a little bit more subjective, and your opinion of what's reasonable may differ from my opinion of what's reasonable. And so if you do have questions about that, then you can ask me on Monday, show me your graphs, and I can tell you like, yep, that's a full credit graph, or no, there's a problem with this and it needs to be. So the specific requirements of these graphs, again, any type of plot that you want, but they must be two different types of plots. And then at least one of your plots must contain two different data sources. So down here, we've talked about only one data source in the plot so far. And down here is an example with two different data sources, so two different lines representing different words. And this is, again, an example of something that we're not going to explicitly cover how to do in class. You'll have to look that up in the documentation to figure out how to do that. And again, the reason I'm making you look stuff up in the documentation is because in practice, in the real world, this library, for example, nobody understands this library, not even the people who wrote it. And everybody has to look up the documentation while you're programming. You never have these things memorized. And so this is giving you practice going through that procedure. So again, properly labeled X and Y axis and a legend for your plot that has multiple data sources. And then the tick labels must be somehow in a reasonable order. So what is defined as reasonable is, again, going to be something that's subjective. But down here, like with these numbers, if the numbers were not in numerical order, that would not be reasonable. If on your y-axis, these numbers were not in numerical order, that would not be reasonable. Any questions about big picture, what the plots or things should look like? Okay. Then the next part of your assignment is that you're going to create a new repository for this project. So this will be a different GitHub repository than you had for your first programming assignments, your web page. And all of these pictures, so the two images that you create and your Python files for generating them and your data sets will all be in there, along with a README markdown file, readme.md, that explains how you generated these plots and shows the plots and basically why they're interesting. Here's the specific requirements of this markdown file. But the basic idea, again, is that anything that's on GitHub is going to be public, available for anybody in the world to look at it. And in particular, it'll be available for your future employers to look at. That your name is associated with your GitHub profile. And when you're applying to data science positions, it's very, very common for recruiters to ask you for your GitHub username information so that they can take a look at your GitHub profile and see what sort of projects you've worked on. And so you will get a grade on this assignment, and it will impact your grade, but that's not really going to be what's going to be the most impactful thing about this assignment or any of our future assignments for you in your future. The real impactful thing will be that people from around the world can look at this, future employers can look at this, and use this assignment, the things that you've actually produced, to determine whether or not to hire you. Any questions about the assignment, Eddie?
What would be the format for the new repository?
So the README files in the markdown format, so the same formatting that you use on GitHub issues or that the compiler was for. And there's just some
no, for the name of the repository.
Oh, the name of the repository. You can name it whatever you like, whatever makes sense for your data set. When you're actually submitting the assignment on Sakai, you're basically just going to submit a link to your GitHub repo, and when I'm grading it, I'll visit your repo, be able to see exactly what everybody else sees, and grade that. Good question. Any other questions so far about the assignments? Let's see. Are we all still tired from fall break? Is that still getting back to the swing of things? How many people, this is your first class back from fall break? About half?
I think this is the only one.
There's sections before.
Yeah, this is like 10 o'clock.
Yeah. Two opportunities, two time slots before this that you could have had class, but
oh, yeah. Well, 8 o'clock.
Yeah. But who wants a class at 8 o'clock? Okay, so grading on the assignment. So each one of your plots is worth 6 points, and your GitHub repo overall is worth 3 points. So no extra credit on this one. If you're looking for extra credit, then the lab will be the place to get extra credit this week. Any questions? All clear? Okay. See a couple head nods. It's clear to 3 people, so that's good enough. We can move on. Okay, so next, what we're going to talk about is the quiz for Monday. So we will, this coming weekend, you have this homework assignment and you have the quiz. And so again, up here up front, there's 2 sheets of paper, or 2 little packets, a big packet and a little packet. The little packet is the actual format of the quiz. It's going to be formatted the same as the last quiz, where there's only 5 questions, and each question will be worth 2 points. I guess the motivation for that is that I want the quizzes to, or what I don't want on the quizzes, I don't want people to feel stressed for time. And so by reducing the number of questions, my goal is that you can really make sure that you're spend as much time as you need on each individual question, and not feel pressured for time. yeah, I guess maybe the downside of that is that since there's only 5 questions, if you miss just 1 question, then you get a higher penalty on your grade. There's also, so besides the practice quiz that has the 5 questions, the other handout is like a question bank. So there's 15 questions in there, and the questions on the quiz could look like the questions from the practice quiz or the questions from the question bank. Most of the questions on the question bank are harder than the ones on the practice quiz. And so my little note here at the top of the practice quiz is that on the real quiz, there will be at least 2 of the sort of harder style questions from the practice. Yeah.
Does that mean that there are going to be 2 questions like the ones in the question bank, or you'll just pull exactly 2 questions?
Good question. The question is, are they going to be exactly from the question bank? And they're not going to be exactly. It'll just be like, there's the format, and I'll substitute out variables and numbers and things. Okay, so the basic idea of this quiz, what we're talking about this week, is something called syntactic sugar. And syntactic sugar is something in a programming language that doesn't let you do anything new. It just lets you do things more conveniently. So everything that we've talked about so far in Python every week, it's always been something new that we're doing. We talked about loops, that we didn't have loops before, or we talked about loading from files, and we hadn't been able to have access to files before. In syntactic sugar, it's just making things a little bit more convenient. And there's the 3 types of syntactic sugar we'll talk about today are syntactic sugar related to for loops and making for loops more convenient. So in order to do this, what I'm going to do is I'm going to load up Python Tutor, and we'll take a look at each one of these questions and see exactly what it does. So this first question right here, the idea of this question, what's different is line 3. This is the part that's different from before. And there's 2 things that are different about it. The first is that rather than looping directly over our list, rather than looping directly over names, I'm looping over this enumerate of names. So this part's different right here. And then the second thing that's different is that in between the for and the in, there is 2 variables instead of just 1. The I variable here, the I represents the index, and name represents the value. This is entirely equivalent. This line 3 right here is entirely equivalent. So I'm going to comment out what line 3 used to be and change it to something that we've seen before. Line 3 is entirely equivalent to lines 4 and 5 together. There's a really common pattern where, range length of names, slight typo. Now line 3 is equivalent to line 4 and 5. So this was a really common pattern that we saw before, where we wanted to loop over the indexes, all the different indices, into a list. And so basically all the different positions. And not only did we need access to the positions, but we needed access to the values. And in order to get the value at a particular position, we do the subscript notation or the square bracket notation. So names at position I gives me the value at position I. So name will be equal to Alice or Bob or Charlie or Dave or Eve. And then I is going to be equal to the position, the index, 0, 1, 2, 3, and 4. Because this is such a common pattern, Python lets you just put it in one line like this. And in the real world, this is maybe like 50% of for loops that I write follow this pattern of for I, comma, something, and enumerate something else. So just to illustrate this, I'm going to comment out these lines again, back to line 3, visualize the execution. And when I press next, so my accumulator then is the empty list. Going into the for loop, you can see that 2 variables were created right here, the I and the Alice. The I corresponds to the position, the Alice corresponds to the value, and then everything else in the for loop happens just like it normally would. So name, Alice, is number, string plus I is 0. So convert that 0 into a string, and then append it onto my accumulator. The second time through, I is 1, name is Bob, so 1, Bob, and append it on to my accumulator, and keep going. And eventually, I'm looking at the position 3 down here. Position 3 corresponds to Dave in my final list, and so it gives me Dave as number 3. The key thing, though, that this, again, this is testing, is that this enumerate function, enumerate, when it's in this for loop like this, you have to have 2 variables to the left of n, and then that's equivalent to this for pattern that we've seen before, plus this variable assignment. Are there any questions about this first problem? Yeah. Okay.
This might just be a general question, but if it's for I and like I is 0, why does that return something? But like if I is 0, then that would be false.
Yeah, this is a good question. So the question is, if we change this to have something like if, so up here I equals 0, and then if I print does this run, then inside the if condition, this right here is a condition. So we look at the truthiness value of I. 0 is not truthy, it is falsy. So this evaluates to false, and this does not run. The for loop, though, these are not conditions right here. These are variables, and these variables are being assigned to all the entries over here. And so for loops never consider truthiness. But if it was a while loop, then we would have to consider truthiness. So if it was something like while I print does this run, the while, this right here is a condition. It's not a variable assignment. These are variable assignments. They're getting assigned to all of these variables. And so this does consider truthiness. You're right that is like a weird sort of asymmetry between while loops and for loops. And that's just one of the things that you just have to memorize about the difference between them. Good question. Any other questions? No.
What if you want to write like third instead of number 3?
If I wanted to write.
Like you want to write first, second, third, instead of like the digit 3.
So the question is, replace 3 with third, 2 with second, 1 with first. Then there's no sort of built-in way in Python with doing that. You'd have to have a bunch of if statements saying like, if I equals 1, print first. If I equals 2, second, 3, third. Yeah. No built-in way of doing that. This conversion right here, all it does is literally make the integer a number. Yeah, Miles.
So you said this returns Alice is number 0, right?
So let's go ahead and.
Also, I was thinking, why doesn't it return Dave instead of Alice?
So the end result is Dave is number 3. Our list down here, our accumulator, has all the different options inside of it. It has Alice is number 0, Bob is number 1, and so on. But we're only asking for the position number 3, so that's looking at the Dave position.
How would you make it return 1, 2, and 3? Or would that just be something?
And so then down here, so it is calculating all these things. Down here, though, is where it's actually accessing it. And so if you wanted to access a different piece of it, then, so say like you're wanting to print the entire accumulator like that, visualize that execution. And now up here it's saying Alice is number 0, Bob is number 1, and it has all of them. On the quiz, I'm not going to ask you to print in a really long thing like that. It'll just be like one element. Yeah, Kevin.
So for the variable names, is this string and it only carries one of the names at a time?
Exactly. So name is a string. It's a string because the names appear, the values of names are strings. If the values up here were numbers, then this right here would be a number. It's whatever is the values in this list up here. Did that answer the question? Great questions. Any other questions about this problem? Okay.
Sort of related to that question. Could you make it so that you could print Dave as number 3, but the word 3 and not the number? Is there a command for that?
There's no easy way to. You have to implement that yourself. Yeah. The only number to string conversion in Python that's built in is just putting quotation marks directly around the number. Okay, great questions. But let's go on to the next one. So I think this, well, let's see, this problem is if you just always remember that you can replace this enumerate line with these 2 lines right here, I think this is going to be a straightforward problem. The next problem is, another question?
So basically, number 3 is, okay, so it's basically, what does the str, where do the str come from?
Question is, what is this down here doing?
Where does string come from?
And let's take a look at an interactive Python for a second. And let's, so we say I equals 4, and we have text equals Eve is number. And if we do text plus I, we get this type error. Int can't be converted to a string because the thing on the left of the plus is a string, the thing on the right of the plus is a number, and so you can't add those 2 things together. In order to add them together, they both must be the same type. So either converting this to a number, which doesn't make sense because there is no number for that string, or converting the thing on the right to a string, which does make sense. So here I is the number 4, string of I is just 4 inside of a quotation marks. And so text plus I does not work, but text plus string of I gives me that. So the string is just necessary to make the addition actually work.
When you say string of I, sorry, when you say string of I, right? Like, what is it looking at in terms of I? I'm confused. Why is it returning 4? Which is it looking at the position?
Just up above, I had set I equal to 4.
Oh,
Is why it says 4 there, yeah. Okay, great questions. Number 2. So number 2 is going to be another relatively easy one. Here, this is just a different way of writing out if statements. And in this way of writing out if statements, you fit everything onto a single line. So this is entirely equivalent to if A greater than A, X equals 42, else X equals 24. So this thing right here to the left of the if is what goes to the right of the equal sign right here. This is the condition, gets placed right here, and then this else gets put over here. When the condition is relatively small and these 2 values are relatively simple, so it's just like a number, just a variable, not a big complicated formula, and and most of the time this condition is true, that's when people tend to use this format. So I'll write those three things out. People use this way of writing if statements when the two values are small. So the values being the thing to the right of the else and the thing to the left of the if. And in particular, they can't be more than one line. The condition is small. So this thing right here, relatively small, easy to see at a glance what's going on. And the condition is usually true. These aren't like hard and fast rules. It's purely a stylistic choice, whether you do this or this up here. Some people find this up here more readable. Some people find this down here more readable. But it's purely stylistic, and it's never wrong to use one instead of the other. And anytime you can use this up here, you could also just replace it with this. So if this sort of syntax is confusing to you, then you just have to know it for this one problem on the quiz, and it's never going to come up again. But if you'd like to take advantage of it, then it's available to you. Are there any questions about this if syntax? LT? When I refer to condition, condition means the thing after the if and between the else. And what I mean by small is super subjective. I would consider this small just because it's hard to imagine something simpler than that. But if there's a lot of ands and ors, then I would not consider it small. And what one person considers small, somebody else might consider large. That's totally subjective. And so if we run this, we'll evaluate this line right here. We get x equals 24. Looking at your ASCII tables, you would see that the capitals come before the lower cases. So this evaluates to false. And so we do the else side of the condition. And we can see now down here in this block right here, that's the same as this is going to evaluate to false. So we'll skip this line and come down here to line 6. And then just printing out x equals 24. So this again is hopefully going to be an easy problem on the quiz. You'll just have to remember what each one of these three locations mean, that the condition is in the middle, the thing on the left is the true, and the thing on the right is the false. Any questions about, yeah?
Yeah, are you gonna quiz us if it's like, instead of just if else, if it's like if and then an if nested in? Or will it just be as simple as that?
Yeah, so the question is, could a quiz be more complicated than something like this? So technically, you could write out something like x equals, and then use parentheses to say 42 if true, else 32, and then another if, some other condition, else 88. You could have sort of nested if statements like this. That's valid syntactically, but nobody would ever do this. Sometimes we use the phrase a code smell. This is a big code smell. That this just smells nasty when I look at it. I can physically smell like rotting socks or something, gym socks, when I look at this. And so your quiz is not going to have something like this on it. The quiz will just be the basic syntax of something that people would actually use. Yep. Okay.
Why would you parenthesize 42 if true, else 32?
Yeah, the question is, why did I put parentheses right here? Let's think about an alternative way of writing these parentheses. What if I had put parentheses like this? Then now this whole thing is going to be what's evaluated if this condition is true. And otherwise it'll be this. Down here, this whole thing will be what's evaluated if this condition is false. Otherwise it'll be this. So these are two slightly different things, because this nested if pattern is so uncommon, I don't even know if it would work without parentheses. And I don't know which one would be the default. So the parentheses would be needed to clarify exactly which of these two things is meant. And, but again, in the real world, nobody would ever do this. Did that answer the question?
So anything you wrote right now, if it's false, it will be 32 or 88. The first one.
So here, we evaluate this if false. Because this condition right here is false, we go and do the 88 and don't even look at this thing over here. So here on line 4, x is 88. And verify that, I'll come over to VS Code, type that up. Copy that. Paste that, hit enter, x is 88. Other questions? Yeah.
When would the first else statement
How could this one right here happen? So if we had, this is true, and this is false, this condition is true, so we do the stuff on the left over here. This condition is false, so we do the stuff on the right over here. We get 32.
And so is this dealing with truthiness, or because 42 isn't 0, then it's false, and then so.
So question is this related to truthiness at all? And the answer is no. So I think we should, if these two things are confusing right here, we should just forget about it. There's never going to be multiple of these nested if statements that you'll ever see anytime in your life. This up here, it's just that, so you have a condition right here. The condition could involve truthiness. Right now, this is just going to evaluate to either true or false. But if I had something like if 0, then this condition right here would be false. So we would go here. So you still need to be thinking about truthiness when this is involved. When there's this if statement, anytime there's an if statement, you need to be aware of the truthiness issues. But this particular question doesn't actually involve truthiness. Okay, so I think these first two problems, just once you get the hang of it, the different syntaxes, they'll be pretty straightforward on the quiz. And the next 3 problems introduce things that are going to actually be a little bit mind-bending, and you really have to focus on them. So on the notes, or the notes for the week, there's a big set of examples down here that we're going to look at. But here on problem number 3, this is problem number 3. This right here is called a list comprehension. And a list comprehension is a way of, sort of a simple way of converting one list into another list. And there's been a handful of times where in class people have asked about different ways to do things, and I've said we can't do that yet, but this list comprehension is a really good shorthand for just converting one type of list into another type of list. And there's 2 syntaxes for a list comprehension, and we'll see both of those. Here, the first syntax, we have the keyword for and the keyword in, both of these inside of the square brackets. So that's what makes it a list comprehension. It's a list because it has the square brackets. It's a comprehension because it has the word for and the word in. This right here is, again, syntactic sugar for this for loop right here. So if we have a for loop that's something like an accumulator and then some variable in a list, and we're doing accumulator plus equals computation, then that's the pattern that the list comprehension does. So this list comprehension right here, I'm going to rewrite it next as XS, my accumulator, being the empty list, and for X in XS, this right here, so for XS in range 10, this right here is the body of, or the statement of my for loop. Notice that, so for X in range 10 up here, for X in range 10 down here, and then this right here is what I'm adding onto my list each time. XS dot append X times X. This right here, again, same as this up here. This right here, same as this right here. So this 3-line sort of pattern of for loops is a very common pattern, and so it can be written instead in just this in this 1 line like this. I'm gonna visualize this, step through this, press next right here, and sorry,
So to really simplify the appending.
If your for loop only has a single append statement inside of it, then you can use a list comprehension to simplify it. Yeah. The arrows over here are not moving for some reason. Let's see. Okay, so the inside of Python Tutor, it's iterating through what's going on inside of this list comprehension. Ignore that. So our XS is equal to this over here. So up at the top, all of our indexes. So each one of the values from range of 10, from 0 up to 9, like this. And then down here are the actual values of this computation of X times X. So when X equals 5, X times X equals 25. When X equals 9, X times X equals 81. And stepping through this for loop, so starting off, XS equals empty, then the first iteration, X is 0, XS dot append, get 0, X is 1, XS dot append of 1, appending 4 when it's 2, appending 3 when it's 9, and so on, each time just appending the next square of the index. And then down here, the actual answer, looking at position 5 and getting, in this case, num equals 25. The key thing, though, is that if you can take this syntax right here and write it out like this, we call that expanding the sugar, expanding from this down to this, then you'll be good on this problem, no matter what it has up here. With some practice, just seeing a bunch of these, you'll be able to look at these list comprehensions directly without doing this expansion down here. But for the quiz, definitely feel free to just write it out as this expanded form and work through this expanded form just like it was a problem from a previous quiz. Ready?
I know it's a little bit more basic stuff, but isn't that range 10 supposed to be up? Okay. No, never mind. I think I got it. Thank you.
Okay. Any questions about this list comprehension syntactic sugar? Okay, so I mentioned there's 2 syntaxes for list comprehensions. In this syntax, there's just a for and an in inside of the square brackets. The next syntax is seen in problem 4. And here we have, so the same stuff inside of our square brackets that we had before, but now there's also this additional if statement over here. This expands to, this syntactic sugar expands to, so starting with our accumulator being empty, for x in range 10. So again, this line right here, same exact thing as what's up here. But now since there's this if statement right here, I'm going to copy that if statement, if x %2, down here, right below this for loop, and then do the appending right below that if statement. So xs dot append of x times x like this. So this if statement only appears if there's an if in the comprehension. If there's an if in the comprehension up here, it comes down like this. If there's not, then you just don't have it. Otherwise, the code looks exactly the same. And again, on the week 7 notes, these are written out in sort of generic form down here. But this is the concrete form applied to this particular problem. Ready?
Yeah, Professor, so this is the truthiness, right?
And then so here in this if statement condition right here, this is going to involve truthiness, because if x %2 equals 0, that's falsy. If x %2 equals 1, that's truthy. So anytime you have a condition, you have to be aware of the possibility of truthiness, but that's not something that's inherent to the syntax here. It's just something that, because there's an if statement, you might have something that's truthy or falsy.
So this would print everything that's odd, or the square root of every number that's odd. Or, sorry, every number that's odd is squared.
Yeah, let's go ahead and run it. And so here our XS list contains all of the squares of the odd indices in the original range. The new indices are not all odd, because you don't go straight from 1 to 3. You have to go to 2 in between. And so now XS at 3 is 49 right here. Again, if you can do this desugaring, then you'll be good for the quiz. It's also fine. Again, if you have more practice, you can just look at this and realize that what the indices or what the values are supposed to be. Either way is fine. In general, people will use a list comprehension when intuitively it makes, I guess, just when you think that this code up here is simpler than these 4 lines of code down here. There's no like hard and fast rules about what makes it simpler or not. It's all just sort of an aesthetic judgment. Any questions about these 2 list comprehension formats? LT?
Is there a reason that it was implemented for not 10?
Yeah, great question. The question is, so the range here is 10. Why is there only 4 right here? And the answer is that this range right here is going from 0 to 10. So let's go ahead and step through this. I'm gonna move up till we get to the for loop. This range right here is going from 0 to 10. But when, say, x equals 0, this if condition right here is going to be false. And so we're not going to go inside of here and append to XS. So we're not adding something to XS for everything inside of this list. When x equals 1, it'll be true. So we'll go inside of here and add something to XS. When x equals 2, it'll be false, so we won't do it. When it's 3, we will do it. When it's 4, we won't do it. 5, we will do it. And so we're only adding the odd x's, x times x, into the list, and that's why it ends up being half the size. So these two problems using list comprehensions are sort of toy problems. But the last problem on the quiz is a real sort of motivating example of why you might care about list comprehensions. And here in this problem 5 example, we have a big list of tweets. I think there's like 8 tweets in this list. And then down here, we want to calculate somehow, like do a computation on this list of tweets. And this computation that we're going to do is we're going to count how many of these tweets actually mention the word Trump inside of them. And that's what this list comprehension down here does, is it counts how many tweets mention the word Trump inside of the tweet. And when doing this sort of data analysis, it's very, very common for people to use list comprehensions in practice. And this is the way that you'll see list comprehensions come up most of the time while you're working. So this list comprehension, the way that we'll understand it is we'll do the desugaring process. So it's equivalent to Trump tweets starting off as the empty list. Then I just copy and paste this for tweet in tweets right here. For tweet in tweets. This again matches exactly this right here, everything up to the if starting at the 4. And then because there's an if, this whole thing right here, I just copy and paste that down onto the next line. And then inside of here, what I append to Trump tweets is the actual thing to the left of the 4. So these 4 lines right here can be shortened down into this 1 line right here. So you probably in your the last week's lab, there's a lot of, you might have written a lot of for loops that look something like this to analyze the Trump tweets. It'd be possible to replace all those for loops with just list comprehensions, and most data analysis sort of people would think that this is a little bit more beautiful than this down here. This is a little bit easier to understand than this down here. At first, when you're getting used to the list comprehensions, this seems just like gibberish. But once you're used to it, then this ends up being a little bit easier than this. Yeah.
This might be a silly question, but if you're looking at the list comprehension line and it says tweet for tweet,
Mm-hmm.
what do those first 2 tweets refer to within the desugar?
Why? Okay, great question.
Which one does it?
Yeah. So this tweet right here corresponds to this right here, and this tweet right here corresponds to this right here. So up above, we had some sort of like computations that we were doing on the variable that we're looping over. In this case, there's no computations that's going on. So these 2 things are the same exact thing. The only thing that's going on is that we have this big filtering clause up here. So we're getting all of the tweets exactly that we had before. If we only wanted to get say the text of the tweet, then we could extract the text of the tweet, and that would be look something like that. So that might make it a little bit more clear about where each of these things corresponds to in the sugared and unsugared versions. Yeah. Exactly. What's in front of the 4 right here is always exactly what goes in these parentheses right here. So it's always, these are the new values of your list.
This is a more general question, but is there a difference between using the append function and doing plus equals?
Yeah, so question is, what's the difference between append and plus equals? With append, the thing over here does not need to be a list, and it will be added as a value. When you use plus equals, both sides of the plus have to be lists, and then it concatenates the lists. So very similar, just depends on the type of what's over here, what you use. So let's go ahead and run this just to see what the answer is. I'll step all the way to the end. See, there's this huge thing down here as it's trying to visualize this tweets dictionary. And, but we get that there are 4 tweets that mention Trump. So again, on the as you're preparing for this quiz, the that question bank has a lot more versions of these different variations of these problems that you should try out. And if you can do all the ones on the question bank, then you'll be totally set for the quiz. But the question bank has some that are pretty tricky on it. But there will be 2 relatively hard problems on the quiz and then 3 relatively easy ones. Yeah, please.
Is there any chance we could look at here one of the ones that you say is a harder one in the question bank, or if we could just like something else?
Let's see, but basically everything on the question bank is just a little bit harder than the ones on the practice quiz. Let me open up. So the last one is basically the same, just a slightly different computation down here. All of the other ones, so you can see so this is a particularly hard one. There's a list comprehension inside of a list comprehension. Being able to just keep track of what's going on inside of here. There's 2 desugarings that you'll need to do. That's probably the hardest of the problems. Then there's with the enumerate, just slightly longer examples. And with the if, just weirder examples showing maybe different edge cases. But the key idea for all of them is do the desugar and then process it in the desugared form.
I guess specific question.
Sure.
Can we look at possibly problem 8, 9, and 10 that's doing something essentially?
Sure, let's take a look at problem 8 here. So I'm going to, let's see, get this into Python Tutor. And it's going to, gonna have to adjust it here a little bit. Few words in it. That words equals word dot lower for word in sentence dot split if t in word, and then printing out the length of the words list. So here, when I'm doing the desugaring, I start off always, whatever the variable is over here, starts off as the empty list. Then I just copy and paste this, everything between the for and the if, right here. And then I just copy and paste my if condition, right here. And then it's words.append, whatever is to the left of the for. Copy that, paste it there. Oops. And so intuitively what this one is doing, why it's maybe just a little bit harder, is just because there's more things in between all the different syntaxes. That there's just more stuff right here inside of my list that I'm looping over. My computation over here is just a little bit more complicated, like that. But the basic principle is still the same. You copy and paste this for the for loop, and copy and paste this for your if condition, and then copy and paste this for the thing that's being appended. And then intuitively, this is going to be all of the lowercase words. So it'll be every lowercase word where we're considering each word in the sentence, where a word is defined by splitting on spaces. And then we only include those words if there's a T inside of it. So this does not have a T inside of it because there's an uppercase T right here. Sentence has a T inside of it, with has a T inside of it, and it has a T inside of it. So those will be the 3 words that come inside of my words list right here. Just to verify that, whoops, place those with proper strings, visualize the execution, go to the last, it says length of words equals 3, and my actual words are sentence, with, and it. Charlie?
Why is the word dot lower function not? Why doesn't that work on the this? Because wouldn't it make the capital T into a lowercase t?
Yeah. So the question is here, this capital T. Why isn't it being made into a lowercase t with this lower function? And the answer is that it is in fact actually being made into a lowercase t. But the key problem is that in our if condition right here, it's if t is in word, not if in t is in word dot lower. The word dot lower is what we're appending to the list down here. If I change this over here to be if t in word dot lower, so over here at the end of the list comprehension, t in word dot lower, then that's equivalent to changing this right here to add the lower. And now it will also include the this. Now there's 4 things inside of it, with this being the very first one. Yeah, so there's a lot to keep track about exactly what each part is going on in different locations. Yeah.
I was going to ask the same question, but I guess what's the point of having the word dot lower in that if everything is already in lowercase? Is it just to see in case, like, if sentence, like if the capital S instead of lowercase, would that just lower like everything in that word? Or
so your question is, what's the point of this word dot lower here?
yeah.
So let's go ahead and take this out. And that is equivalent to taking out this word dot lower here. So now our if condition will be checking if the T is in the lowercase version of the word, but we'll be appending the original version of the word. So now when we visualize this execution, go to the end, we can see that this right here is capitalized instead of lowercase. When I had this the word dot lower before, when it was word dot lower right here, then this was lowercase right here.
Wait, but I thought it wouldn't transfer over because you put if t, like if lowercase t in word.
Yeah, so the if condition right here checks on the lowercase version of the word, but you remember that our strings are immutable in Python, so we can never change the value of a string with a function like this. So this creates an entirely new string, which is the lowercase version of the word this, and then this version of the string right here still retains the, exactly. Yeah, great questions. So that's what makes these other problems on the question bank harder is that it combines all of this other knowledge from all the other stuff. So we have about 4 minutes left in class. I wanted to talk one last thing about plotting for the last part of class here. And so this file that I have opened up here, Wednesday section 1.py, again, it's loaded, or it's available on GitHub. And what this file does at this point is, so I'm getting this file not found error, no such file or directory data. And anytime you have this file not found error, you need to check your path. So I'm going to cd into my week 7 folder and now rerun this. And this is the output that I'm getting from this plot. And So real quickly, we'll see that, well, you can see that this plot's not very pretty. So this would not be a full credit plot on your homework assignment. And the reason for that is there's this weird like backwards line over here. What's causing that weird backwards line? And what's causing it is the order that I'm plotting my data points in. So this is a really common problem that you're likely to run into on your homework assignment, is that the order of your data points is not correct when you're trying to plot it. And so here, just a quick overview of what this file is doing. First, this is loading all of the tweets from the JSON files, putting them into this tweets variable right here. Whenever I'm writing my own code, I tend to group my code into sort of paragraphs with a comment that's sort of like the topic sentence of that paragraph that just tells me what this paragraph is doing. And so I can just read this comment instead of trying to work through what the details of this paragraph are doing. And then this next thing down here actually counts the number of times that Obama is mentioned on each year in those tweets. And I'm storing that in this dictionary right here, Obama counts, where the keys are the year and the values are the number of tweets in that year. And remember that the ordering of dictionaries is non-deterministic. So here is the current ordering of the results that my computer happens to give me. Other computers would give something different. And when I use this, so I'm just printing out Obama counts like this, 2016, 2017, 2018, then back to 2009, 2010, 2011, 2012. And so here my X variables along the X-axis are all the keys from Obama counts. Along the Y-axis are all the values from Obama counts. And then just plotting that how we did before. Running this. So here you can see 2016, 2017, 2018. This is where it's starting because that was the first value in the XS, 2016, 2017, 2018. And then it came back over here to 2009, 2010, and so on. So the reason we get this backwards line is because the order of this XS list is incorrect. If I rerun this again and you look at the output of the XS list right here, you can see that the ordering here is the same order that it plots it in. So in order to plot these correctly, make it look nice, you'd have to sort the XS like this, and then also somehow change the Ys to be the corresponding positions in the XS. And I'll real quickly use a list comprehension for that. YS equals Obama counts of key for key in XS. Like that. And now if I rerun this, it's going to plot them in the correct order because the XS and the YS lists are in the correct order. The takeaway from this is just that whatever you plot is going to be, or whatever you have in your variables is going to be exactly what is plotted. And so you just need to make sure that what's in your variables is actually exactly what you want to have plotted. The main way that people lose points is inside of these variables right here, you don't have what should be plotted. You have something that's closely related to, but not exactly what should be plotted. That's the end of our class for today. If you have any other questions about this or about list comprehensions, I'm happy to answer them now. I have my office hours now. Otherwise, I will see you all on Friday or next week.
No, go. Sure. Just a quick question. Is this file on GitHub? Because I don't see it on week 7.
If it's not up there, then
I don't think it's up.